Cool. Okay. We shall get started. So hopefully you're all here to hear about modern observability and OpenTelemetry. If you're not, then please leave now. We are about to take off. So one of the things that I want to talk about today is how we've evolved the way that we build applications, but perhaps not evolved the way that we observe applications. And that's really where modern observability comes in. Now, I asked this question recently. Does everybody know what that is? Because apparently there are people in our industry today that do not know what that is. It's called a server rack. It's where all of your code runs. There's lots of them in the cloud. Now, back many, many years ago, that was the observability we had. A little blinky light. Blinky light goes fast, we're making lots of money. Blinky light goes slow, we're not making so much money. Blinky light goes off, leave the building because someone's going to ask you to fix something. I jest, but I mean, that's really the information that we had back then, and things have evolved. And that's what we're going to be talking about today. So my name is Martin Thwaites. I work for a company called Honeycomb. We are a back-end for observability data and all of that kind of stuff, but I'm not here to talk about Honeycomb today. You want to find me, I'm on all of the social things under martin.net. Come and find me, ask me questions. And I also do office hours and things like that for free if you have some problems around OpenTelemetry and stuff like that. So what is it I mean when I talk about modern observability? Now, this is where I have to do a little bit of an apology. Because if you've in any way been following me or a lot of the people, a lot of the leaders in the observability industry, over the last sort of 12 months or so, we came up with the term Observability 2.0. And I sincerely apologize, because that led to Observability 3.0, and Observability 3.0 final, and then Observability 3.0 final draft. It was the wrong idea. The intention that we had at the time was the idea of how do we evolve how we observe applications. What does it mean to observe an application in 2025? If you think back to how we built applications back in 2010, 2005, even as fast forward as far as sort of 2015, 2020, how we built applications during that era is very different to how we build applications now. We do cloud native, we do microservices, we do event-driven asynchronous systems. However, the way we observe those systems hasn't really changed. And the idea behind talking about 2.0 or 3.0 was really about changing people's mindsets and making people more open to evolving the way that they do observability. So that's why I've kind of changed that tack now, just really to talk about modern observability, as opposed to the way that we've always been doing things. And this is not about a breaking change. That's the reason why the 2.0 isn't the thing for me. It's because it's not a breaking change, it's an evolution. We're looking at the data we've already got, and we're augmenting it, and we're making it better. We're making it easy for us to observe applications. So specifically, what do we mean by modern observability? Well, ultimately, it comes down to outcomes. It's not about the data. It's not about the telemetry signals. It's not about what logs you create, what traces you create. It's not about ditching logs, ditching metrics, moving to events, eBPF, all that kind of stuff. That's not what modern observability is about. It's about the outcomes. It's about what do we get from observability? What's the reason why we are investing so much time in observability? What it is to us, who are the people who are pushing these new techniques, is thinking about we get systems that we can debug better, whether that's locally or even earlier in the software development lifecycle. These applications become something that we know intrinsically. It's not about knowing the code that we write. It's about knowing the system as a whole and being able to debug that thing better. Ultimately, it's about it being an engineering issue, not an ops issue, not something for DevOps engineers, not something for infrastructure engineers, not something for product engineers, for all engineers. Observability is not something that we add on afterwards. Modern observability is something that we bring all the way back through that software development lifecycle. Now, I hate the term shift left, specifically because it has this connotation that we're taking something that's on the right and we're moving it onto the left. So we stop doing it on the right and start doing it on the left. What we're really trying to do is make it everybody's concern, get everybody involved because everybody uses the data every day and everybody is improving that data every day. It's everybody's responsibility. And we do that through telemetry data. Now, I know I said it's not about the data, but data is how we get there. Now, one of the things that I think people struggle with when it comes to thinking about observability is the actual types of data. Now, there are only 3 types of data. I'm not talking about 3 pillars. I'm not talking about 3 signals. I'm not talking about logs, traces, metrics. There are 3 types of data. There is unstructured data, strings of text, things that we've been using since dawn of time, printf. You know, we would write something out to the console. It is unstructured data. We still do that today. There's still a lot of systems where this is done and is still useful. That's different to structured data. And I'm being a bit liberal with the definition of structured data here because it could be formatted data in JSON. It could have an actual structure. It could have a schema to it. But ultimately, it's data that is separated and indexable and all of this kind of stuff. Structured data could be a structured log file. It could be a bit of trace data. It could be the new events data, which is coming out of OpenTelemetry at the moment. But ultimately, it is structured. That's all it is. And the third type of data is pre-aggregated data. You might call this metric data with a big M. Those are the only 3 types of data that we have. Unstructured data allows us to search free text, all of that kind of stuff. Structured data allows us to group by, filter, aggregate, build graphs of aggregates of that data because it's all well structured. Pre-aggregated data is where we take a load of structured data, whether it's in our application or in our pipelines, and aggregate it ahead of time. Normally because we know what graphs we want to create, what visualizations we want to create on the back end. So we pre-aggregate that data because it's cheaper that way, and then we can use that in a very efficient way. Those are the only types of data that we have to work with. Forget about the idea of traces, logs, metrics, and understand that the underlying data types are the thing that are important. And that leads into something called OpenTelemetry. Now, at this stage in OpenTelemetry's evolution, I would be very surprised if people in the room have never heard of it. You may not be completely familiar with it, but I would imagine that most people have heard of it. So why is OpenTelemetry so core to what we're going to do with modern observability? Now, I want to say I'm going to get some code and some demos. Don't worry. There's actual interesting stuff. Don't worry. This is just the preamble. So why is OpenTelemetry something that is important to this? If we think back to where we were in the 2010s and the 2015s, what we had was data types weren't a thing. We'd use unstructured logging data because it was more universal. We'd do it, we'd output it to the console, and everybody can work with just strings. That was fine. What we didn't want to do is we'd instrument with a vendored agent. We'd go off to one of the big providers. They'd give us an executable. We'd throw it on the same server as IIS and do a bit of config, and woohoo, we've got all the things. But what would happen is it wouldn't be in any way custom. And the reason is because nobody wants to go and spend the time instrumenting their code and adding all of this extra data because, well, we might move provider at some point. I don't want to invest all of that time and effort into making this. It's not going to get me that much further, so I'm not going to do it. If we fast forward to OpenTelemetry days, OpenTelemetry has the promise that we get to instrument our code once. We don't need to think about, oh, I might move provider. It means that as an engineer, we can concentrate on making our data rich, regardless of where we're going to be sending this data. We can concentrate on trying to make this data contextual and interesting and useful beyond the generic, you run a website, it's got a database, it runs on an app service. Because if that's all you're doing, just go and use the auto instrumentations from somewhere, that's fine. It's going to tell you everything you need to know. But the vast majority of systems are more complicated. And we can do this in a completely vendor-agnostic way, because it has things like a protocol that means that all of the stuff goes out the back in a standardized format, and every provider uses it. And it's also backed by a foundation, one of the biggest software foundations in the world. The same company behind a little thing called Kubernetes, if you've heard of it. The number 1 and 2 projects, depending on which metrics you use, are OpenTelemetry and Kubernetes, depending on which one number 1, depends on A, what month it is, and B, whether there's been any CVEs in Kubernetes this month. But ultimately, those are the top 2 projects coming out of the CNCF, so you can trust it, which means that as engineers, we're in this golden age where we can really think about the actual engineering behind observability. We can think about what our data looks like, we can think about what's useful, and we can spend the time doing it. And one of the things that makes this really cool is the semantic conventions. And this is where we're going to be spending a lot of time on this talk about. Now, semantic conventions are names for things, common things that people would understand. There's an entire group of people that sit in a room and debate what http.request.method means. I swear they are really interesting people most of the time, but I can't sit through those meetings. I don't know about you, but those meetings where we talk about naming things are just boring. But they do that for us. So anything that's generic across our industry, they've already done. But that doesn't mean they know our system. And that's what we're going to do today. What they do is they go through all of these different signal data from resources, which are the things that produce the telemetry. That might be your pod in Kubernetes, your instance in app service, scopes, the libraries. And they work out what those names should be. The spans that you generate, like a HTTP span, they define that a HTTP span needs a http.root attribute, a URL.path attribute, a span kind of server, if it's for ASP.NET Core, a span kind of client, if it's for HTTP client. They spend the time and do this so that backends can reason about it. Now, they've also brought this into something called events. And events is brand new in OpenTelemetry. It's not actually a ratified thing just yet. But events is the evolution of logs. Think of it as logs, but with a schema. So that when you produce your log, every time you produce a log that says database connected, it will always have the same data no matter which application you do this in, no matter which language you do this in, they will have a structure. If you've got something in your code where you go, got user from database, you can guarantee that there's a schema on it, and it will tell us that it'll have a person ID, a database name that it got it from, a duration of how long it took, etc., etc. So you can see where we're going now is actually treating our telemetry data in the same way as we treat database design. We're designing a structure. We're designing how we're going to use this. And that comes into something called telemetry data strategy. And that's something where I'm spending quite a lot of time with our customers at the moment. So what do we mean when we talk about data strategy? One of the problems that we find with engineers adding telemetry is they don't know what to include. well, what things should I put on my span? Is there a certain set of attributes that you'd like? Because, I don't know, should I put the social security number on there? Should I put the unencrypted password? Don't put either of those on your telemetry, just to be clear. So you include things like, what should I avoid? We put in things like, how should you name these things? We think about conventions. We think about, well, how should I format the values? So fun story, I've talked about this for quite a while, quite a few of my talks, where how do you define your pre-prod environment? And a customer, literally a few months ago, had four different names for their pre-production environment. They all meant pre-prod, but they had pre-prod, pre-production, pre-prod, all one word, and PP. This is the problem that we have, because our data is in a bad state. In data engineering terms, it would be a data swamp, not a data lake. And what we're really trying to do is make our telemetry data more useful to us. Make it so that as engineers, we can actually use this to get real insights. So how do we define a good data strategy? Well, our goal really is to help people fall into the pit of success. Because developers are lazy. That's a good thing. Lazy developers build the best products, especially if they have to use the product themselves. And that is why it works with telemetry. Because the thing that they're building is the thing that they're going to use to understand their system when things go wrong. Helping them fall into that pit of success. And the thing that we have to do in order to do that is make it simple and logical. Work out what somebody would guess. And if that's what they would guess, that's probably what we should use, because consistency is the most important thing. We produce examples. Tell them that this is what it should look like. But just like we do when we build an API contract and we build an API endpoint, we produce SDKs for them. Opinionated ways to use our SDK, our APIs. We provide SDKs, we provide code helpers that allow them to do it. And that's where we went with OpenTelemetry. We developed a tool called Weaver. So Weaver allows us to be able to define application telemetry schemas. It allows us to be able to say, and allow our applications to say, this is what my telemetry is going to look like. This is what the uniqueness of my telemetry means. I'm going to produce an attribute called this that does X, which allows you to reason about it. We build attribute registers that allow you to be able to say lots of stuff about an attribute, not just the name, not just the format, but a lot of things. What that allows us to do is do automatic code generation, build constants, build helpers, build methods. It also allows us to build documentation polls. Now, I know this is really disappointing for a lot of people, because I know you all like manually crafting documentation and writing documents and sticking them in Confluence. I know that's what a developer's real desire is, to sit and write documentation. But this is going to do it for you. So, if you really want to write documentation, don't use Weaver. But it's going to allow you to write this documentation that will explain to people how they should be generating telemetry, because developers are lazy. Nobody wants to sit in a bike shedding meeting for 4 days trying to work out, should we use http.request.method or just http.method? Because request doesn't really matter when it's a method, because there's no outbound method. So we'll just use request.method, right? Yeah, but I don't enjoy that. But if somebody's already told me what it should be, that's great. Now, one of the other really cool things that we can do is something called live validation. So within the Weaver product, which is all open source, free, it's nothing to pay for. I'm going to show you a demo of how all this works. It allows you to be able to run your telemetry through it, and it will tell you if you're generating attributes that are deprecated, generating attributes that aren't defined, generating attributes that are extending namespaces in OpenTelemetry when you shouldn't. Now, it's really easy. It uses this wonderful language called YAML. In YAML, indents are absolutely not a problem. There aren't 4 million different ways to write multi-line comments. Definitely not. But what it allows us to do is generate a bit of YAML with a load of context on it. So we can write things that are obvious, like in this particular example where ndc.speaker.firstname, which is the attribute name, we can say, well, it's the first name of the speaker, but we can also write a note on there that says if a speaker only goes by one name, that's the only field that's going to be populated. Don't put it in surname, put it in first name. So if the application has only got one single field on it, then just stick it all in first name. These are notes that actually allow you to do some really interesting stuff. Now, it wouldn't be a talk in 2025 if I didn't mention AI. Now, as a certified AI realist and not a fanboy, I don't normally like talking about AI. However, in this scenario, these two things go really well together. Because AI needs context in order to provide insights. AI does not know what first name is. It's got a good idea, but it doesn't know when it's going to be used in your application. It doesn't know the specific context of when you're going to use it. And that's fine, but when you put in widget, when you put in foobar, it doesn't know what these things mean, but you do. These schemas are how we're going to train the AI that you're going to use in order to provide insights, whether it's locally, if you're using Aspire and you're going to use Copilot inside of Aspire to tell you about your application. If you can actually put into your application and say, I'm generating this telemetry for X, Copilot's going to be able to use that as context. If you're doing this in a production backend, providing this context to that backend so that it can explain what a trace is doing. Because it's got the context. Without that context, you're hindering those AI tools. And a lot of the time, those AI tools are useful. I'm not saying that the replacement or anything like that. That's a debate we can have over beers later. But this does make those AIs more useful. Now, it's pretty simple to use. And when I talk about generating documentation, what we've done is allowed you to be able to use all of the generators that we already have. So all of this stuff is what we use in the OpenTelemetry community to generate our conventions. All of those things that I put up on the screen before are generated using Weaver. They run through that Weaver contract, and they generate markdown files that then end up on the OpenTelemetry website. So we actually dog food this. And you can use our same markdown generators, and I'll show you how we do that, but it's literally that command, and generate a documentation portal. Throw it through MKDocs or Read the Docs or wherever you want to put it. Throw it into a GitHub Pages project inside of your application. And then you've got, hopefully, a good documentation portal that you can point developers to. And now they can no longer say, well, I didn't know I needed to use that attribute. Did you read the docs? Because you know when you get that from all of your people, they go, did you actually read the manual? You go, no. Now you can say that to them. Did you read it? I'd spent loads of time down this really curated markdown thing in a GitHub page, and you didn't read it. Oh. But we can provide these templates, but you can also provide your own. If you don't like the way that we generate the .NET conventions, then you can generate your own. It's just Ginger templates. These are not bespoke to the way that we do things in OpenTelemetry. These are templates that are apparently used everywhere. I've never seen them anywhere else, but apparently they're used everywhere. It's a standard language. And that's pretty much what we use to generate the C# ones, and they come out a little bit like that. And you get loads of constants that you can use in your code for all these attributes. But you shouldn't stop there. That obviously gets you some consistent naming. But what I advise people to do is go a step further. Think about your engineers. Think about what you do as a developer experience when you're writing code. You write abstractions. Build helper methods. Path of least resistance. If you would like to enrich your current activity in .NET with speaker information, and you've got some attributes in there, just add a helper method that allows somebody to do it. It's not particularly hard. So, let's have a quick look at what this looks like. This is a repo that you can absolutely go and have a look at. Please, demo gods. If everybody could just like cross fingers and toes that this works, because this has failed that many times. Ignore those errors. That's just Aspire. OK, so I built this demo using .NET Aspire. If you haven't heard of .NET Aspire, where have you been hiding? It's a .NET conference. I counted at least 15 talks that mentioned Aspire, so I'm not going to explain what Aspire is. Hopefully that will give us syntax highlighting. OK. So what I've done in this particular project is we have a conventions folder where I've defined some conventions. Because this is a greeter application, you say your name and it will tell you how old you are. It's really accurate. It uses random. And it will tell you how old you are. It's not particularly complicated. But it's got some attributes in here where we've said, well, first name means this and surname means that. Here's some examples, the email and some examples. Now, I've put all these as stable, but they could equally be in development and things like that. Now, what I've done then is I've told Weaver, using this container here, is that big enough, or should I go bigger? Go big or go home, I think. How's that? Good? Right. OK. So what we're doing is, and this is one of the things that it's all written in Rust, by the way, so if you really like Rust, then you should absolutely be using this. But it's also, we generate a container for you so you can run it all in a container. So you can use a few commands, and I am going to build this as a component for Aspire at some point soon, and you'll just be able to just point it at your directories. It'll be all hunky-dory. But what that's going to do is it's going to use the conventions in that folder. It's going to use the generic markdown files that we provide in OpenTelemetry and generate some markdown files. And then what I'm going to do is I'm going to use something called mkdocs, which is a static site document generator from those markdown files, provide a little bit of a theme, and I'm going to run that. So I'm not going to start up as... Oh, did I killed it, didn't I? Yeah, OK. We're going to have to restart Aspire. Everybody go get a coffee. Because when you've got all these projects and service bus, it takes a while. OK. We should start getting something. There we go. So while all that boots up, the docs should be booting up sooner, though. So we've got this generate docs. One of the cool things about Aspire is you can actually run tasks in the background. So you don't have to actually have a running application. What that's doing is just running Weaver, but it's running the generate command. So it's going to take those mounted folders and generate some stuff and then just exit. And then we're going to run this mkdocs one, which allows us to see an attribute registry and then see little tables like this, which show us all of these things in there. This is obviously a very simplistic example, and it's only including attributes right now. You can do resources, so you can say that when we deploy things, our deployment criteria means that you need to include these attributes. Maybe it's a team name needs to be included on there. You can actually say that it needs to be in a resource attribute, that thing needs to be existing. So, cool, right. Now, just a quick note about this solution, because we're going to use something that's in here next, is it also uses an OpenTelemetry collector. Now, that's part of OpenTelemetry's offerings. Why I've got that on force, I don't know. But what that allows us to do within OpenTelemetry is duplicate our telemetry data. So in Aspire, the way Aspire works is it adds some parameters to every one of your projects that will say, forward all your OpenTelemetry data to the Aspire dashboard. What the collector component does is say, no, 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 forget about Aspire. We don't like Aspire. We do. It says, don't send it to Aspire, send your telemetry to me. So it takes that telemetry and then forwards it back onto Aspire. But it allows us to do loads of cool things, like generating metrics on the fly. So we can do things like tail sampling, we can do augmentation of telemetry. But one of the things that we're going to be using today is duplicate outputs. So it's going to be forwarding all that telemetry over to the collector, and the collector is going to be sending it over onto the Aspire dashboard, but then it's also going to be sending it on to Weaver as a live check. So in Weaver, we have up at the top. So we have this. And this is our Weaver live check. And what Weaver live check does, where are we? That one, that one. Come on, come on. There we go. So what's going to happen is we're going to have that collector, we're going to have our logs, traces, and metrics going over to the collector. It's still going to be going onto our back end. Now, you can run this inside of a production system if you want and just use sample data into Weaver. That's what the collector will be able to do. Sample some data and just send some data down to the Weaver live check. So you've got some live version of this. But what we're going to do is run it in Aspire. And Aspire promotes this idea that we run a lot of our applications. We run all of our telemetry through there. So the collector is not going to interrupt what we're doing with the Aspire dashboard. You're still going to get all of the data in the Aspire dashboard. But what we're also going to get is this little Weaver live check container that's going to give us exception reporting. It's going to tell us that we've added a new attribute that doesn't exist or something that doesn't conform. So we're going to have our Weaver live check. Whoa, no, you don't want that. Go away. Don't you go away, though. Right, so in here, we've got live check. Oh, don't tell me you've died as well now. No, it's because you don't have an endpoint. This is a bug in Aspire, by the way. But what Weaver live check is going to do is it's going to tell me that I've added an attribute, and you saw that in our collector config where it says collector is enabled. That isn't an attribute that's defined anywhere. There's no definition for what that attribute means, so our backend doesn't know what it means. But I've also added, if you look at the bottom, it's kind of hard to see just because of the way that the red works there. But it tells me that the message.count attribute, A, doesn't exist in any registry, but also that it's extending an existing namespace in OpenTelemetry, which is a problem. Because OpenTelemetry defines the message namespace. So if you put stuff in that message namespace, there's a chance that you're going to be overriding some conventions that OpenTelemetry expects. And if it's in OpenTelemetry specification, the chances are the vendors are going to assume that that exists, and they're going to assume it means a specific thing. So if you decide, I'm going to use http.root for the, I don't know, the road that they're running on, I don't know. And all of a sudden, your dashboard in your back end that's auto-generated based on your telemetry is showing weird information. And this allows you to be able to look at that. There's a lot of stuff that we're going on, and I want to be clear that Weaver is still in its early days. It's very useful as it is right now. We're enhancing it as we go on, literally enhancing it as of last night with something that didn't work. But we're enhancing it as we go. And this sort of thing, this putting out these red ones that say there's a big problem here, throwing those into backend so we can see the exceptions as you're running your code. So you can start playing with it right now. And this is a repo that you'll be able to download. So when we're generating these conventions, there's a couple of things you need to keep in mind. There is a hierarchy. Now, OpenTelemetry define semantic conventions. There are entire committees of people worldwide coming from multiple vendors that build all the things that are generic. If it exists in OpenTelemetry, you should absolutely use it and not try and create your own convention for it. And the way that Weaver works is we have dependent conventions. So you define your own conventions and say, and I also want to use these. So we use the OpenTelemetry semantic conventions. Now then what you should do as an organization is think about the things that are important to you. What cross-cutting concerns do you have? And there you can generate some more conventions. Is product a concept that is wider than an individual team? Do lots of people use the term product? In this case, yes. Define what product.name is. Define what product.id is. Product.category. Product.category.id. Define those namespaces and those conventions at a global level inside your organization. Have a naming committee if you have, everybody's got that person in their organization who really likes to do bike shedding on naming. Just you go over there and do that, yeah. Just don't bother the rest of us. That's on you. And they can come up with those namings. But then you leave it down to departments and teams. Maybe they've got something that's specific to them. You don't need to have one central registry that everybody needs to go to Dave, and Dave needs to approve your names. If Dave doesn't approve it, then you can't do it. You can define these at multiple different levels. You can even get as low as service. And that is absolutely where you should be. Each individual service, each individual, maybe it's not service, but a repository, should define the conventions that are used inside that repository. You can say that I'm going to use these third-party products, these third-party libraries which have their own conventions. So I'm going to use them, and I'm going to use the OpenTelemetry ones, and I'm going to use the ones that our organization has got, and I'm also going to use these ones that I've got. Between all of them, they should all be defined. And then you can use Weaver to tell you. I want to finish up with a bit of do mores and avoids. I hate the do and do nots, because my context is not your context. I can go in and say, don't do this, and they go, yeah, but on a Tuesday at 3 o'clock, can I actually do it? Yes. Avoid these things if you can avoid them. Do more of these things if you can do more of them, if they're applicable to your organization. Do encourage local conventions. Talk to your engineers. Get them to think about the conventions that they're using. Get them to implement those conventions. Go and validate their registries with them. And encourage them to do those locally. And as they become a wider concept, promote them over to Dave. Say, Dave, I've got this really cool thing. Do you like it? I mean, he won't, because he's Dave. But encourage this promotion of going, we've spent a lot of time curating the way that these things work. So do encourage that idea of collaboration, of going, we define what product means, and we think we're really close to a really robust spec. So can we just use that? Don't worry about deprecating conventions. Telemetry data is not built to withstand 10 to 15 to 20 years. The conventions that you use will cycle over a month because you use this data when you're debugging systems. If you're debugging a system that failed 6 months ago, do give me a call because I think your incident response processes need a little work. You use this to debug things that are happening now or in the last few weeks. So deprecating a convention and replacing it with a new one is only going to be a problem for 4 weeks. 2 business cycles, generally. So don't worry too much about trying to get it absolutely right the first time. Use the stability levels to say this is in development. Everybody, can you try these ones out? See if it works for us. Does the structure of these things work for us? No, great, okay, let's move things out. Don't procrastinate too much and wait for the right one. And the final thing, please do not enforce that people cannot add attributes unless Dave approves them. Because nobody will ever write custom telemetry. Everybody will be scared to write custom telemetry. Because, well, that means I need to go and have a conversation with Dave, and he smells. You know, I'm sorry if anybody's called Dave, I'm not talking about you. Other names do exist. But if you are enforcing this and saying, no, you can't produce any telemetry unless it is documented, unless it exists in a central repository, even unless it exists in your local repository, nobody's going to be generating custom telemetry. And custom telemetry is what will save your ass. That is what will allow you to be able to debug those niche issues in production. You should be adding all of this, and this is proper engineering for telemetry. Because now we're not just slinging bytes on a disk and hoping that at some point in the future, these things will be useful. Now, one last AI mention before I leave you. One of the really cool things that we can do with this, because we're generating these registry documents, and because we're using Weaver to do this, if you've already got an application, and that application has a ton of random attributes all over the place, and you're using something like Claude or Copilot or something like that, you can ask Weaver, you can just run your application, ask Weaver to output a list of everything that isn't documented. And ask something like Claude to go and look at that document, look at the code, and generate a Weaver document for it. And it will generate all of that registry. It will use the context of your code to understand what those attributes mean. I'm not going to say it's perfect, but it's going to get you close. So if you're scared about this thing going, I've got 4,000 attributes and I'm not going to document all those, don't be. Let AI do it. Let the computer generate it for you so you've got a good starting point. You can start with this today. It works. It might not say V1 on it, but it's used at scale in massive organizations already. That's me. Hopefully that was useful to you. I'm going to be around for the rest of the day, and I'll be around for questions as well. But Thank you very much.